Hi, everybody. Coming to you live from Hogwarts. We are going today doing section 1.3. Two topics: Cartesian products. That's the first topic, and power sets. That's the second topic. Let's get started. I'm going to get rid of my picture. Somehow I just find it makes it easier if I get rid of that. Okay. So Cartesian product. That's basically the set of ordered pairs. So if you have A cross B, that's going to be the set of ordered pairs A comma B, where the first element A is part of set A, and the next guy B is part of set B. And so when you see an ordered pair, like in graphing, like you've always seen all these years in algebra, that is really an element. Each ordered pair is an element of the Cartesian product of the real numbers times itself. So, oops, why is that not? Okay, so let's say now, let's say A is a set 1, 2, 3, and B is a set 4, 5. So A cross B is going to be 1, 4, 1, 5, 2, 4, 2, 5, 3, 4, 3, 5, 3, 4, 3, 5. And I have to make this. I looked at it. I didn't realize I went that far. So how many units? Notice that there are 6 elements. That the cardinality of A cross B is the cardinality of A times the cardinality of B. Now this cross over here and that cross over there are these. They're not the same cross because this is a multiplication symbol. This means the cardinality of A, which is a number, and times the cardinality of B. So it's the number 3 times the number 2. That's where you get the 6 from. The cardinality of A cross B, that's how many of these ordered pairs are there in this list. There are 6 of them. Yes. Okay. So now A cross A is 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3, 3, 1, 3, 2, 3, 3, and that, if you notice, is 9, which again is the cardinality of A times the cardinality of A. So it's funny, even though this is not a multiplication symbol, it kind of is related to the multiplication symbol in the sense that the cardinality winds up being the product of the individual cardinality. So the cardinality of the cross product winds up, of the Cartesian product, I'm sorry, cross product is something else. For those of you who took linear algebra, or if you took Calc 3, you're familiar with cross products. I meant to say Cartesian product. Anyways, we could define the Cartesian product of 3 or more sets. A cross B cross C is ordered triplets, A, B, C. And again, this is something you see in, when you do three-dimensional, in Calc 3, you do a lot of three-dimensional stuff, again, in linear algebra as well. So that's the story. It's often, we use exponents. Why not? So A to the third, where are we here? Oops. A squared is A times A the third is da da da, and there you go. Okay, now this is what we call ordered n tuplets. Okay, so that was Cartesian products. It's pretty short, and now we're going to go into power sets. Power set is a pretty cool concept. Power set is a set of all subsets of a given set. So the power, if A is any given set, power set of A is a set of all subsets of A. And now, of course, for the empty set, the 2 extreme cases, the empty set and all of A, are both included in P of A. So the empty set is considered a subset of A, and the entire A itself is considered a subset of A. Now, the power set of the empty, the power set of the empty set, meaning that how many subsets does this have? Well, it's 1. It's not 0, it's 1, because the empty set has itself as a subset. The power set of the set containing the element 1 is empty set and 1, so it has a cardinality of 2. The power set of the set containing 1, 2 is 1, 2, 3, 4. It's 4. So there are 4 elements. Let's do the cardinality of the set 1, 2, 3. So first, let me just want to copy this, put this into now they're leaving this as a little challenge here. They want us to guess a general formula, um, and but let's see if we can get some. Let's do some examples. That we can start guessing. Meanwhile, I want to go here, go to my Google Docs, open them up, and let's go. Let's go right here. There you go. Da 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 da. Okay, so 1 point. This is actually 1.3. Okay, let's look at 1.3. So where was I? Was just here. And let me copy that. Oops. Copy. And okay. So let's look at the power set. I'm not going to do a fancy P. The power set of 1, 2, 3. So of course you have the empty set. Now I really should put this all in a giant set here. So it's a. So of course you have the empty set, and then you have the set containing 1, 2, and 3. Let's do the smaller sets. I want to do smaller sets first. So the set containing 1. Let me put the commas in here. Okay, so the set containing 2, the set containing 3, the set containing 1, 2, set containing 1, 3, the set containing 2, 3, and the set containing 1, 2, 3. And the cardinality equals 8. I didn't bother writing cardinality, but the cardinality equals 8. And notice the cardinality here, that's cardinality of 1, that's 2, that's 4, and this is 8. So you may 1, 2, 4, 8. These are the successive cardinalities. Let's look at the power set of 1, 2, 3, 4. Let's see if we can do that. The power set of 1, 2, 3, 4 is as. I like to look at examples of some power sets. So we saw that the power set of the null set is just one. It has a cardinality of 1. It's just a null set. This has a cardinality of 2. There are 4 subsets of 1, 2. So notice 1, 2, 4, 1, 2, 4, and then 8. Now you may say, hey, it looks like you may think, hey, maybe it keeps on doubling. Well, I would concur with that, and let me show you a really nice way of seeing why that's true. So I have all these 8 sets, right? Now what I'm going to do is I'm going to copy it. I'm going to copy these 8 little guys in there. And I'm going to add a 4 into each one. So I'm putting a 4 in there. I'm putting a 4 in there. And 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 another 4. And another 4. And another 4. Oops. So, because if you think about it, all of the subsets of 1, 2, 3, 4, either they have the element 4 in them, or they don't have the element 4 in them. Well, if they do not have the element 4, then it's the same 8 guys that I had over here. If they do have the element 4, well, it's going to be 4 plus something else. Plus what? Well, it's going to be 4 plus each of these things that I have over here. So this is 4 plus the empty set. That's 4 plus the set 1, 4 plus the set 2, 4 plus the set 3. So I'm basically just adding, and that's it. And this is all my possibilities. So the cardinality is going to be 16. This is just a way of seeing why this is one way of seeing why it's going to keep on doubling. If I would do 1, 2, 3, 4, 5, it would be the same thing. I would first copy everything I had over here without 5s in it. Then I would copy everything with a 5, and the cardinality would be 32. So basically, the cardinality of the power set. I don't have a way to write. I don't know how to write cardinality. Well, I guess I'll just make these things. I'll use this. The cardinality of the power set of 1, 2, 3, ... n is going to be equal to 2 to the nth power, and that is a yeah. So yeah, so I guess I may as well put these symbols here. Cardinality symbol. This is the cardinality symbol. The cardinality symbol looks kind of obviously it's kind of like an absolute value. Let me just put it in just to be. So yeah, so this is. Hope you're enjoying watching me just. This is the kind of stuff which I normally have to just. Okay. Anyway, this is a very famous thing, and that's now you're seeing where it comes from. So there you go. That concludes our broadcast for today, and that is it. That's the end of 1.3, and we'll see you guys next time. Bye, everybody.